In this video, we are going to study about NMR spectroscopy of isotactic, syndiotactic, and atactic polymers. This is polyethylene. If we replace one of the hydrogens in one of the carbons with an alkyl group, we get a monosubstituted polyethylene. That would be like this. So this is a monosubstituted polyethylene where we have replaced one of the hydrogens with an alkyl group. This carbon is now a chirocarbon because it has 4 different substituents on it. It has an alkyl group, a hydrogen, and chains on either side. We can write this polymer chain as, because the chain here and the chain here are different. So we can write this chain as like this. The carbon atom is pseudochiral because the spatial arrangement of the chains on the left and on the right side of the carbon atom is different. That is what makes it pseudochiral. Okay. This carbon is not technically chiral because it does not show optical activity. Optical activity is shown only if the atoms or the groups attached directly to the carbon are different. In this case, the groups attached to the carbon in the polymer chain may be same, but the spatial arrangement of the chains are different, which is what makes this carbon pseudochiral. If the substituent R is on the same side every time, then it's called isotactic. If the substituent is on opposite side or it alternates, then it's called Syndiotactic. Here, the R group is alternating on either side. So this would be Syndiotactic. If the R group is randomly arranged with no pattern, then it would be atactic. So these are 3 types of isomers based on the arrangement of the alkyl group around the monosubstituted polyethylenes. Let us focus on the methylene groups in the backbone of the polymer chain for the 3 isomers. These are the pseudochiral centers, and we are going to focus on the methylene hydrogens. for isotactic polymer. If this group R is bulky, then there is restricted rotation between the carbon-carbon single bond here. Because of that, these two hydrogens are in different environments. If we call this as hydrogen A and hydrogen B, then hydrogen B is in an environment between two alkyl groups, and hydrogen A is in an environment with two hydrogens nearby. So hydrogen B and hydrogen A are not equivalent from an NMR perspective. So HA and HB will give different peaks, and HA will split because of HB and HB will split because of HA. So we will get two doublets because of this for the methylene groups. Let us consider Syndiotactic polymer. In Syndiotactic, let's focus on the methylene hydrogens. Each of these methylene hydrogen is flanked between a hydrogen and an alkyl group in the neighborhood. So, if we name these as hydrogen A and hydrogen B, then they are equivalent. So, they are the same. So, in an NMR, these two hydrogens will give a single peak with the intensity of two hydrogen atoms, and there won't be any splitting. This is a picture of the configurational sequences of a monosubstituted polyethylene. If we consider two consecutive pseudochiral centers in the chain, then we are looking at a dyad. In this case, the two pseudochiral centers have the same configuration, so it's called Meso or denoted by M. In this case, the two consecutive pseudochiral centers are having opposite configurations, so it's called Racemic and denoted by R. Note how in Meso the two methylene hydrogens are not equivalent, and in Racemic the two methylene hydrogens are equivalent. Coming to triads with three pseudochiral centers, we can have three kinds of triads. First is isotactic, in which all the pseudochiral centers are meso with respect to each other, so they are denoted as meso, meso, MM. If the pseudochiral centers are randomly arranged with respect to each other, they are called heterotactic, and here we see that these two pseudochiral centers are meso with respect to each other, and these two are racemic with each other, so it's called MR. If the pseudochiral centers are alternating and they are opposite with each other, then they are syndiotactic and represented as RR because these two pseudochiral centers are racemic with each other, and so are these two. So RR. We can see that for dyads, we can have two variations, meso and racemic. For triads, we can have three different variations, meso-meso, meso-racemic, and racemic-racemic. Now let us look at tetrads. with 4 pseudochiral centers. Let's look at what happens when all pseudochiral centers are meso with each other, that is, they are having the same configuration. In that case, it will be MMM, and because they are in the same configuration, let us look at the methylene hydrogens. The methylene hydrogens are not equivalent because A is flanked between these groups and B is flanked between a different group. When you come to MMR, let's look at the methylene hydrogens. The methylene hydrogens are again different. Similarly for RMR, when we come to MRM, we see that the two methylene hydrogens are in the same environment. This A is in between one of this kind and one of this kind, and this A is also in between one of this kind and one of this kind. Let us consider polymethyl methacrylate. This is acrylic acid. If we replace this hydrogen with a methyl group, we get methacrylic acid. If we replace this hydrogen with a methyl group, we can form the ester methyl methacrylate. We can polymerize methyl methacrylate at this double bond to get polymethyl methacrylate. This is an NMR of polymethyl methacrylate for the various isomers. At 0.00, we have tetramethylsilane, which is our reference. And then we see the OCH3 group, which is the ester group here. And then let's focus on the methylene group. The methylene group is here, and we see that for isotactic, we get two doublets. For the two, because the two hydrogens are not equivalent, they give different peaks and they split one another. For Syndiotactic, the two hydrogens are equivalent, so we get a single peak. In isotactic, the two pseudochiral centers are Meso with respect to each other. In Syndiotactic, the two chiral centers are Racemic with respect to each other. And in Atactic, you get Meso and Racemic, so you get a single peak for the Racemic and you have these doublets for the Meso.